properties. We could do it inside the literal when we first assign the object, or we could do it using the dot syntax after the fact. And we know that we could use curly braces instead of the dot, right? In which case animals would be a string and would need to be in quotes. And the value can be whatever. We've used strings, we've used functions as values. They could be arrays as well. So it's an array here. Functions as properties. Just like anything else, just put that function on the right side. You can access it using either of these two syntaxes. Piece of cake. We're masters of this now. We looked a little more at functions and the differences between writing functions in different ways. Regular old function expressions, the original way to do it. No problem. We could assign a function to a variable by putting an anonymous function on the right side of an assignment. It's subtly different in behavior. We don't get hoisting if we do it this way, right? So if you just use a function expression, you could call that function higher up in the code than where it's actually defined, as long as you're within the same scope as where it was defined. And we know we can write functions using the function keyword or with the arrow. And we know that the value of that magic variable this depends on not where we wrote the function, but how it's invoked, how it's called. So let's look at the different ways of invoking a function that we know about. The usual way, name a function parentheses to call it. What does this equal? You don't need to know any more. You don't need to know the context in which it was defined or anything. That is enough information. The fact that we called it that way, just name a function parentheses, you can always know what this is going to be. Anybody remember? When in doubt, what is this? What is it by default? Window. Doesn't make any sense, but that's how it goes. A normal function called the normal way. This is window and is thus not useful. So what's the difference here? We're still invoking the function the same way. But now that function happened to be defined with the arrow. Now we need a little more information. This may or may not be window. This will be whatever this is, basically on the line before we created that function. So if const sum equals is on line 4, then whatever this was on line 3, it is inside the function. No matter where you're calling it from, if you use the arrow function to define it, then this is whatever it was in the context where it was defined. That's the difference that the arrow function makes. What if it's an event listener? This next slide is actually a lie, the way I wrote it. But suppose the function is an event handler. We set up an event listener that calls that function. What's it going to be inside that function? Doesn't matter where we wrote it. Who said it? Yeah. It's not going to be window. It's going to be the target of the event. So, doesn't matter where you wrote it. Doesn't matter if it's a method of an object. It's going to be the target of the event. If it was called by an event. So the reason my next slide is actually a lie is because I made it an arrow function, and making it an arrow function changes that, right? What about methods? So here, thing is an object, and explode is a method of that object. So what if we then call that by using thing.explode? What is this going to be inside explode? It's going to be thing. It's going to be that object. Not because it was defined inside thing, but because it was called that way, because it was actually called as a method. Again, if explode had been set up as an event handler, wouldn't have mattered that it's a method of thing. But since we actually called it as a method, since that's the invocation style we used, this is that object. So here's a little experiment. I haven't actually tried to do this thing on, yeah, I know. Haven't actually tried to do this thing on CodePen, so I hope CodePen follows these rules. But let's try something real quick. Let's say we just have a button and we have an object with a method called say yeah that alerts yeah this. Then we say document dot query selector button. Oops, yeah, it already indented it. Dot add event listener. Click. App dot say yeah. Open close parens here. No. Second argument needs to be a function. If we did that, it would be the return value of the function, which is undefined in this case because there's no return statement in there. What's it going to do? Let's find out. Click me. Yeah, object HTML button element. Right? It's being invoked as an event handler. So this is the event target. All right, now what if we say app dot say yeah down here. Same method. Yeah, object object. In other words, which object is that anyway? It's actually pretty hard to tell from that. A Boolean, yeah, good idea. So we haven't even talked about triple equal yet. Okay, yeah, chill out, CodePen. Okay. Yeah, false. This triple equal app? Yeah, true. So this is this object because we called it using method invocation. Because we called it whatever dot that. The same exact method had two different values for this depending on how it was invoked. So you got to keep that in mind. The same method could behave differently as far as this goes. So what if I said, let's just change this back to just spitting out this. Now it's going to do it again. Yeah. You know. Now what if I say, okay. Oh my gosh. That's better for right now. Okay. What if I say app.say yeah dot bind and then call it With bind, we can make this whatever the heck we want. We can just make it some string. We don't care. We're loose cannons. They should probably take our gun and our badge. The mayor just called, said you did $1 million of damage to the city. You're a loose cannon. We can bind it to whatever the heck we want. Now, why did I put the parentheses where I did? Why didn't I say this? Then what would we be calling bind on? Not a function. The return value of the function, which in this case is nothing. We didn't return anything, so it's undefined. Calling bind on undefined doesn't do us any good at all. In fact, it does us harm. That help? That make it a little clearer how some of this nonsense works? Sorry, I shouldn't call it nonsense. These perfectly reasonable design decisions made by a dude who was in a hurry to hit his demo date 20 years ago.
Anybody read the article about this that I posted in yesterday's? Highly recommend it. Even a year after learning JavaScript, I still had some ambiguity about what this was in certain contexts, and that article really cleared up a lot of it for me.
There's a lot of stuff like that. Like truly, I probably wrote JavaScript for, and again, I'm dating myself a little, 15 years, probably a good 15 years before I really had any idea what this was. It was JavaScript, the good parts, that did it for me, that book. But that book is, although it's kind of entertaining as such things go, and it's not very long, it is pretty dang technical. But if you want to, once you know the language a little bit, you just read those first few chapters about objects and functions and things, and he explains how they work so dang well. But keep in mind, it was written before ES6 was a thing, so you're definitely learning the ES5 reality. But understanding that really well still helps, because you may not always be building from scratch. You may be working with other people's existing code, which may or may not be written in ES6.